I'm Anil Kumar, and now in this video we are going to understand how to sketch transformed logarithmic functions. Well, let me share with you the most popular question from my students. It's very simple. It says, so we can sketch the transformed logarithmic function, but first tell us what are the key points and how to sketch the base function. That means just log of x. Well, I think that is the most critical question to be answered, and that is why this example is there before you. It says, explain steps to sketch the graph of y equals to log 3 of x. So it is just a base function. Once we understand this, then in the following videos, we can try to sketch transform logarithmic functions. Now, coming back to the question, what are the key points to consider to sketch this function? Excellent question, and probably you'll get the best answer in this particular video. I am just looking at this part and I'm saying, well, I do know one thing about this function. What is log 3 of 3 to the power of n? Can you answer this question for me? That is the key thing. Log of base 3, 3 to the power of n, as you know, is just the number n. And that gives me all the key points which I should be considering to sketch the logarithmic function, correct? So now here are my values. So the x values which I am going to consider will be in this form, and the y values will be in this form. That is to say, we are looking for log 3 of x, and for the x values I am going to consider values like 3 to the power of n. So let me begin by taking 3 to the power of 0. I always begin with the 0. So what is 3 to the power of 0? We don't have to think much, right? 3 to the power of 0 is that 0, right? So we'll write 0. Remember, log of 3 to the power, log to the base 3 of 3 to the power of n is n. That is what we are doing, right? So when I write x as 3 to the power of 0, I get what? I get log 3 to the power of 0, which should be 0. You get my point, right? So this is what helping us to get the key values. What is 3 to the power of 1? 1. What is 3 to the power of 2? 2. So these are the values which help us to find the value of the function, correct? Now, what is 3 to the power of minus 1? It should be minus 1. How about 3 to the power of minus 2? Minus 2. So these are now the 5 key values. Now when I write 3 to the power of minus 2, you understand, what am I saying? When I write 3 to the power of minus 1, what am I saying? The x value is 3 to the power of minus 2 is 1 over 3 square, which is 1 over 9. 3 to the power of minus 1, the x value is 1 over 3. Anything to the power of 0, the x value is just the number 1. Anything to the power of 1 is the number itself, so the x value is 3. 3 square is 9. So, in short, the x values are powers of 3 if the base is 3. If the base is 2, I will take all these values as 2 to the power of n, okay? Now, if I write 9 here, y equals to log 3 of 9, I will get 2. That is the y value, correct? So, looking into this, we can write down our coordinate points, right? So, let me write down x, y, the coordinate points very clearly for you so that you can sketch, right? Okay, so let's begin by the first one here, which is 1 over 9 gives me minus 2, 1 over 3 gives me minus 1, 1, 0, 3, 1, 9, 2. So these are the values which help us to sketch the graph. Now there are two other very critical values. If I follow this pattern, if I write n value as very large negative, that is to say, if I am approaching negative infinity, negative infinity, in that case here I am approaching a very, these are the values 3 to the power of negative infinity. Okay, so we are approaching negative infinity, right? So y is also approaching negative infinity. These are the n values. I'm saying 3 to the power of negative infinity, kind of very large negative value. Okay, so that means when x is approaching 0, let me write like that, right? 3 to the power of negative infinity is kind of x approaching 0. If x is very close to 0, y is approaching that negative value. Is that okay? And if it is like 3 to the power of 100 will be what? It is going to be 100. Let's put it like this. Okay. And you can say, what is 3 to the power of minus 100? It will be minus 100. Okay, that's also good enough. What we are saying here is that as x value approaches 0, y value approaches negative large value. When x approaches large positive value, like 3 to the power of 100, right, big value, y approaches a large value, right? That is what we are trying to say here, correct? So we get, as x approaches infinity, y approaches infinity, but as x approaches 0, y approaches negative infinity, correct? So these are your base values which you should be considering to sketch logarithmic function. Now on your graph paper you can actually just plot, right, x and y axis and graph it. So what you notice here is that we do have a vertical asymptote as x approaches 0, right? So it's kind of approaching this place. Let me sketch this first and then explain. Graph will always be like that. And the critical points to mark here, of course, are the x-intercept, right? So we have x here, y values there, and this is always at 1, correct? So that is the point, which is this point. Is that okay? So at 1 we have, I'm in this point. Okay, yeah. So this is what it is, right? So x-intercept will be at 1. 3 to the power of 0 means x value is 1, correct? So at 1 we have 0. At 3 we'll have 1. So it is this 1, let's say 2, 3. So this value will be, so at x of 3 we'll have 1 here. Do you get the idea? Correct? And 1/3 of this value, so that means 1/3 will correspond to minus 1/3. Well, I've taken a very small section. You can plot the other points also and show your result. But in any case, you can see the behavior or the characteristics of logarithmic function here. And clearly, as x approaches positive infinity, y approaches positive infinity. As x approaches 0, do you understand? From the positive side, you cannot approach from the negative side. Y approaches negative infinity, correct? So these form the characteristics for a logarithmic function which you should be considering for any transformed logarithmic function, correct? So what I would like you to do is, whenever you sketch a transformed function, in the base function, consider the vertical asymptote. Let me call this as the vertical asymptote. Vertical asymptote, whose equation is x equals to 0, or the y-axis. Do you see that? So what you need to consider is the vertical asymptote x equals to 0 and at least these 3 points. At least, right? So that is bare minimum which you should consider, which I am considering here. So that is my vertical asymptote. Is it okay? And these 3 points. Now once you have to transform the function, show the transformation of at least these 3 points and the vertical asymptote. That should give you fairly good graph and fetch you excellent marks. I hope that helps. Thank you and all the best.